This evening what we're looking at is the Motorola Communication System Analyzer 2600. This is an image of the manual that accompanies this test instrument. We have under test this evening a Cobra 132 radio, and this is the manual that accompanies that piece of equipment as well as the lab and the images that show some of the physical layer connections that are required to perform a transmit path test and a receiver path test. When we power up the instrument from the toggle key at the bottom right hand corner, we will next want to put on the antenna immediately into the antenna port. The red LED to the immediate left of it should illuminate. The purpose that we want to putting that antenna on immediately is to mitigate any possibility of putting wrongly other connections to that physical layer connections to that particular port that could damage the instrument. You'll notice the soft keys are at the bottom, control each of those blocks on that task menu there. Notice to the far right there is a more, which allows you to plug in additional test instruments such as AC volts, distortion analyzer, synad meter, and others. The next thing I want to draw your attention to is this vertical green line in the cursor zone shaded area. That represents that vertical line on the display. The DISP soft key controls the display and how we will see the signals that we are monitoring or producing. The vertical line that runs between the RF soft key and the audio soft key are represented by this horizontal line right at that point on the display. The audio part is where we use where the modulation is and signal is constructed that we will use to test the receiver path. The RF zone is the top part of that cursor zone where we can change from monitor to generate, and that changes the test instrument into a generate mode, which allows the receiver path of a radio to be tested. These tab keys and arrow keys direct us through the menu. On the second line of the RF zone, we can select narrow band or wide band. In the next line in the RF zone is where we can set the frequency that we are concerned with dealing with monitoring or generating. The frequency can be keyed in using these soft keypads, or alternatively it can be dialed in using this tuning dial right there. The next line in the RF zone indicates whether or not we want to add attenuation to our signal. It's set to 0 dB right now, but we can add attenuation in increments of 20 dB by changing it on the soft keys as indicated below. You'll notice at this point we are on the antenna, which means that this is the active input agent at this time, the small whip antenna. We can alternatively, with this soft key, change the input to the RF input-output port, which is N-type male and female connectors. The rest of these connectors down here for synad, for modulation out and audio out, are all BNC connectors. Be sure to ensure that you set the brightness for your particular eye. In the monitor mode, on the antenna, if I dial in a frequency of 92.9 as I have, we hear that mostly noise is at that location on the spectrum. But let's see if we can't tune in. Some intelligent signal. I'm incrementing in 500 kilohertz denominations. I'm in the basement also. This lab is located in the basement, and so over the antenna reception is a little bit more challenging than it would be just if I were to be on the other side of these walls. I'm in a concrete enclave that even with great resolution makes locating an intelligent signal over the air something of a challenge here. You might hear something at that location, but we also notice there's fair bit of clipping going on. Let me go and look for another. Yes, there's a little bit of signal there, but the signal level is quite weak, coming in at around -98 dBm. So it's very weak here at this time. But the purpose of this demonstration is to demonstrate the features of this instrument. We would need to tune in the frequency of the radio under test, and we can push to talk and at that point we will see on the display the input level measured in dBm. We have an option at that point to look at that signal in watts or microvolts, depending on our choosing. Now on the receiver side, to create a 1 kilohertz test tone, we go into the audio display and we set the fixed 1 kilohertz tone with 3 kilohertz of bandwidth. And we want to ensure at this point, this it looks like a squiggle line, but it's really a sine wave. We want to ensure that that's set to continuous. And when we have it set to continuous, in the monitor mode, on the RF input output, we set it to generate mode, and out comes the 1 kilohertz test tone, as you can hear over at this time. So anyway, that's a quick overview of the Motorola 2600 communication system analyzer. It has a number of valuable features, and it's a powerful network analyzing tool in the wireless RF world. Good night.